from autonomous agents and value alignment to open source sandbox training and minuscale world modeling. This week's papers map out where AI is headed next. We'll look at how agent behavior changes across environments and harnesses, why reusable infrastructure may be the key to scalable agent training, and how a new world model can generate realistic 1-minute video with strong control and stability. If you want to hear how models are becoming more capable, more embodied, and more aligned, this episode is for you. Let's explore the first paper, Agent Value Bench, a comprehensive benchmark for evaluating agent values. Agent Value Bench is the first benchmark built specifically to measure values in autonomous agents rather than in text-only LLMs. And the paper argues that these two modalities are not value identical. The benchmark contains 394 executable environments across 16 domains and 4,335 value conflict tasks spanning 28 value systems and 332 value dimensions, with every case co-synthesized by an automated environment, task pipeline, and then curated by human psychologists. Unlike prior multiple-choice value tests, each task includes 2 psychologist-vetted golden trajectories and a trajectory-level rubric, so scoring is based on observable agent behavior, tool use, and state changes. The authors evaluate 14 frontier models, including GPT-5, 4, Claude Sonnet 4.6, Gemini 3.1 Pro Preview, DeepSeek V, 3, 2, and Qwen 3, 397B, A17B, across 4 harnesses, Vanilla React, Codex, Claude Code, and OpenClaw. Their central empirical result is a value tide. Model value profiles converge into a shared pattern, but harness choice can shift values by as much as or more than changing the model, with 74% of within-model harness-induced adherence, ranges exceeding 1, and 26% exceeding 2 on the 0-10 scale. Deliberate skill steering is even stronger than prompt steering, recovering on average 3.7 of 5 target ranks versus 1.3 of 5, and in one GPT-5-4 case, exactly reproducing the target ordering. The paper concludes that agent alignment is moving from model alignment toward harness alignment and skill steering. Let's explore the second paper, Orchard, an open source agentic modeling framework. Orchard introduces a thin, open source, Kubernetes native environment layer for agentic modeling, arguing that the main bottleneck in training autonomous LLM agents is not orchestration, but reusable sandbox infrastructure. Orchard Env exposes only sandbox lifecycle, command execution, file I, O, network policy, and a REST API, yet achieves 0 to 8 second average command latency, 100% success across 1,000 concurrent sandboxes, and roughly 10 times lower estimated cost than managed sandbox services when spot instances are used. The novelty is not just the runtime. Orchard pairs this environment with 3 training recipes that reuse the same backend across domains and harnesses. In software engineering, Orchard SWE distills 107K trajectories from Minimax, M2, 5, and Qwen, 3, 5397B, then adds credit assignment SFT over unresolved trajectories via retrospective value estimation and balanced adaptive rollout for sparse reward RL. With Qwen 330B, A3B, thinking it reaches 67.5% on SWE bench verified, outperforming comparable open models and improving 45.5 points over the untuned Qwen 330B, A3B instruct baseline. In GUI navigation, Orchard GUI trains a 4B Qwen 3 VL backbone on 2 6K curated web tasks and reaches 74.1% on Web Voyager, 67% on Online Mine, 2Web, and 64% on Deep Shop, averaging 68.4% and beating its 235B teacher on the harder benchmarks. In personal assistant workflows, Orchard Claw uses only 0.2K synthetic tasks to reach 59.6% pass at 3 on Claw Eval, rising to 73.9% when paired with a zero-claw harness. The paper's central claim is that a minimal environment abstraction enables trajectory data, RL rollouts, and evaluation protocols to transfer across domains while exposing harness coupling as a major obstacle to generalization. Let's explore the third paper, Sana WM Efficient Minute Scale World Modeling with Hybrid Linear Diffusion Transformer. Sana WM introduces a 2.6b parameter open source world model that natively trains for 1 minute, 720p camera-controlled video generation, rather than distilling from short clips. Its main novelty is a hybrid linear diffusion transformer that alternates frame-wise gated deltanet with periodic softmax attention, giving constant memory long context modeling while preserving exact long-range recall. The paper reports that pure cumulative linear attention becomes unstable at minute scale, while the proposed one, Squirt DS key scaling, stabilizes training and avoids NANDs. Control is handled by a dual-branch camera conditioning design combining latent rate UCPE and raw frame plucker ray mixing, which significantly improves 6-DoF trajectory fidelity. On the 6.0 second benchmark, the refined model reaches rotor 4.5 degrees and transor 1.39 on the simple split, versus 10.47 degrees and 2.01 for Lingbot World, while maintaining comparable V-bench overall quality at 80.62 versus 81.82. Sana WM is trained on only 212,975 public clips with metric scale pose supervision recovered by a robust VIPE pipeline using Pi3X and Moge 2, then refined with a second stage long video refiner trained by truncated Sigma flow matching and LoRa adapters from LTX2. The full system trains in 15 days on 64 H100S, generates a 6.0 second clip on one H100, and its distilled variant denoises a 6.0 second 720p clip on a single RTX 5090 inches 34 seconds with NVFP4 quantization. Overall, Sana WM delivers up to 36 times higher throughput than prior open baselines while improving action following and temporal stability, cutting delta IQ from 3.79 to 1.17 on the simple split after refinement. That's a wrap on today's AI paper highlights. Thanks for watching.